Hi everyone, I'm going to talk about lead code problem 815, bus routes. First, the problem, we are given a bunch of bus routes, and each bus just loops forever through its list of stops. We start at a stop called source, and we want to get a stop called target. The question is, what's the minimum number of buses we need to take? One thing to notice, we are counting buses, not stops. And each case is easy. If source equals to target, we return 0 right away, because we don't even need to get on a bus. The moment I saw the words, the list number, my first instinct was BFS, because BFS naturally finds the shortest path in an unweighted graph. The real question was, how do I build a graph? My first idea was pretty direct. I thought, let each bus be a node and connect two buses with an edge if they share at least one stop. Then just BFS starting from every bus that passes through source. It sounds clean, but when I did the math on the complexity, it didn't work. The number of buses can go up to 500, and each bus can up to 10 to the power of 5. If I compare every pair of buses to check if they share a stop, there's really a big number. The time complexity will be 500 times 500 times 10 to the power of 5. It's a so big number. And then I'm scanning stops on top of that. It was going to time out for sure. The sum of rows dot length less than or equal to 10 to the power of 5. So I try to think reverse thinking. Instead of pre-computing bus to bus edges, I used the stop as a bridge between buses. What I did, it was build a dictionary, stop to buses, where the key is the stop and the value is a list of buses that pass through the stop. Then for BFS, my starting points were not the source stop itself, but every bus that covers the source stop. Each of those buses starts with a count of 1. This line, because I've taken 1 bus. Then the BFS step looks like this. I pop a bus off the queue. First, I check if the target is on the bus route. If yes, I return the current count. If not, I go through all the stops on this bus. For each stop, I look it up in my dictionary to find every other bus that also passes through this stop. Those are the buses I can reach with one more transfer. I push them into the queue with count plus 1. There are two tricks here that I think really matter. The first one is I keep a visited set for buses. So every bus only gets processed once. The second one is a little less obvious. Once I use a stop to expand to new buses, I clear the list in the dictionary for that stop. Why? Because otherwise, later on in the BFS, some other bus that also passes through this same stop is going to look it up again and do the same expansion, which is wasted work. After I clear it, each stop really only gets used once. But if you delete this line, this problem will also be accepted, but the time complexity will degenerate to 500 times 10 to the power of 5. If you add this line, the total time complexity will be the 10 to the power of 5 only. Yeah, that's my walkthrough for this problem. Thanks for watching.